Welcome everyone to another episode of It Depends podcast. This time I have a repeat customer, Jordan Tigani, a very good friend of mine who I've known him since days when he was at Google and I was at Gartner. And in 2019, we were actually supposed to speak at Google Cloud Next. And I think it's 2020 because COVID happened and then that was canceled. Many of you know Jordan Tigani. He is the original part of the BigQuery team, and now he is a founder, co-founder, and CEO of MotherDuck. Last time we spoke was It Depends episode number 8, and this one is 66. So we've come a long way from April 2022. So Jordan, I am delighted that you've taken the time to come on this podcast.
Yeah, great to get a chance to chat with you again, and I'm glad you didn't learn your lesson from having me on last time.
No, it's always a pleasure. You are one of the most delightful people to talk to because I live and breathe databases, and that's what you do. So you're a storehouse of information. For those who don't know there's a very interesting backstory to when Jordan came on my podcast in April of 2022. He was about to launch MotherDuck. So right before the podcast recording, he called and he said, I don't know if I want to talk about MotherDuck because we are still in the process of finalizing the shape of our company, and it wouldn't be right for me to talk about it on the podcast without letting my closest people know. So we decided to talk about DuckDB because DuckDB is a foundation. So what excites me about this about what Jordan has done is that he started the original team of BigQuery started with nothing but just an idea and took it to over $1 billion in revenue. And then he went on to repeat the same thing, starting a new company called MotherDuck. And let's see where that lands, right? Jordan?
It was. I actually just went back and rewatched the episode, and it's just funny because April of 2022. Sorry, I'm getting into feedback. But anyway, April of 2022. We had really not. Didn't have anything. I had just started like thinking about what we might build, and it was about 2 weeks. The idea was about 2 weeks old, so we didn't have a team, didn't have anything. But actually watching that old episode, it's like all the pieces were there, and so all of the stuff that we talked about was basically the things that went into MotherDuck, and so it's cool to see how much has changed, and we've made a lot of progress since then. But it also is interesting to see how much hasn't changed. Like sort of the fundamental ideas are still what we're building today.
Amazing. Let's dive into it. By the way, are you getting echo on your side? Is that what you?
I was a little bit, but I think it's better now.
Okay, because I was wondering if I should put my headphones on.
I think it's okay.
Okay. Okay, sounds great. So in fact, I went back to look at my notes, and you had shared with me a one-page cheat sheet of what MotherDuck was going to do. I still have it. So just in case, for historical reasons, it'll be worth something one day. So
yeah, I came up with that one pager. Kind of didn't have any pitch deck. I was talking to some investors, and then somebody said, well, you should just kind of write down what you're going to do. And so I kind of wrote like a small idea. And I think so far that's actually still pretty relevant. Hopefully it stays that way. Hopefully we don't have to pivot over and over again.
Yeah, amazing. So let's talk about your career before we go deeper into MotherDuck and DuckDB. Because you also had a stint at Single Store. So can you just walk us through where you started your career and all the way up to today?
Sure. Yeah. I mean, I started at Microsoft back, in the .com boom days, and was working on the Windows kernel, and ended up in Microsoft Research, kind of working on compiler technologies, and worked at a couple of startups. I thought I never wanted to work at a big company again, and then ended up at Google, really because Google they really got big data. I was so excited about big data, and I just thought this is where the world is going, and I really loved building data processing systems. And Google was at the time, I think, who was it, Doug Cutting, the guy who created Hadoop, said Google is like living 3 years in the future and sending us messages into the past, and it felt that way at the time. So anyway, started at Google and kind of found myself on this team that was supposed to build a data marketplace. We decided to build BigQuery instead. Back at the time when, at Google, your manager could tell you to go build one thing and you could build something different, and that was considered your prerogative. Very different world at Google these days, and perhaps for good reason. But we ended up building BigQuery, and was super fun to be part of that journey and to sort of build something that kind of scaled from zero to I remember being excited, when we had 10 million in revenue, and then we had we finally had a petabyte in storage, and then we had exabytes in storage, and hundreds of I don't have to kind of advertise BigQuery because it seems to be doing fine on its own, but I ended up in a engineering leadership role, ended up in a product leadership role, and then after about 10 years I was like, this is a long time to work on the same thing, and jumped over to SingleStore. Was a chief product officer, got to sort of run engineering and product, and really help them reboot their SaaS offering. Creating a database as a service out of a shrink wrap database is hard to do. It's hard to do sort of culturally in an organization. And I learned a ton about, what a late stage startup looks like, or what a startup looks like. And just, Google kind of hides a lot of the machinery from you. And, you kind of don't see how go-to-market works, or marketing and all these other things that become super important in a real or normal organization. And then kind of saw this database, this kind of upstart database, DuckDB, showing up on some benchmarking reports, and kind of giving us a run for the money at SingleStore. Is this looks sort of interesting, and how is this so good so quickly? And the more I started poking at it, I'm like, wow, this can solve a lot of problems that BigQuery couldn't solve, SingleStore can't solve, and somebody should really take this and build a SaaS service around it. And then I'm like, maybe that should be me. I've built 2 SaaS services, SaaS database as a service, and so yeah, I went and kind of I first went to the DuckDB folks to see if they'd hire me, and they weren't interested in kind of building a cloud service. They really just wanted to focus on the core database, but they said, hey, we'd love to partner with you. And then, accidentally talked to some VCs, and they kind of gave me some money to get started. And amazing people kind of sort of came out of the woodwork and said, hey, we want to work on this with you. And it was just sort of crazy, acceleration of being in the right place at the right time, and kind of it seems like this is the right way to go. And and now 2 years later, we kind of now have a generally available product. We've got a bunch of customers, we've got a bunch of excited users, and we're off to the races.
And you just went GA recently, correct?
Yes.
When was that?
That was in June. So we had kind of built for a year. We went beta last June, and kind of got a bunch of feedback, and kind of started to build up a user base. And then what we have is basically, it's good. It's and we're getting feedback from customers that it's good and they like it, and they can use it to solve problems in real world situations, and running it in production. And so we said, hey, let's go generally available, start charging people for it. And so yeah, that's we've been GA for about a month now.
That is amazing. I remember, I think it was Snowflake Summit the week of when you went GA, because I went to your party in Mina Gallery in San Francisco.
Yeah, we had, because there was Snowflake Summit, there was 1 week, and then the next week was the Databricks Summit. I think we went GA at the same time as the Databricks Summit, because that was also when we had our people in duck suits. We had a bunch of 10 people dressed up in duck suits, and we had them just we didn't want to disrupt anything. We just had them sort of wandering around, dancing and stuff outside of Moscone Center when the Databricks Summit was going. We did it when Hannes, who was the founder of DuckDB, was giving his keynote at Databricks. So it was on topic, because to advertise his keynote, and just kind of just showing off, or showing, hey, ducks are fun. So I've since we first talked, kind of my life has started to revolve around ducks. You can start to see them in the background here.
I have seen you come on to stage at Data Council Austin, fully clad in a duck suit, and give the keynote. So, and although you did get rid of the duck suit once you started talking, but I have some wonderful pictures of you and me surrounded by these ducks holding these protest signs, which actually is a great pivot, because you went from big data to small data, something that you call an active data warehouse. What is a small data, and why do you feel that this is the right place to be?
Yeah, so I think this is sort of one of the key things that the company was founded around, was just that big data is not actually relevant to most people, and kind of where the boundary for what constitutes big data has been kind of increasing and exponentially over the last 20 years. And so to the point where you can do a lot on a single node, on a single laptop, that you might have needed 100 machines to do in the past. And I think when I was at Google, I used to do a lot of analytics on seeing what size data, what shape data people were actually using, and 90% of queries were sub 100 megabytes. Most people had sub 10 gigabyte data warehouses, total data sizes, and and then almost nobody ran queries more than a terabyte. I remember we had a bug where pretty much anything over 5 terabytes wouldn't work, and really nobody noticed, because there was a problem in Shuffle for a while. And it was we had one customer that noticed, and we had some of the biggest customers in the world, Home Depot, Walmart, HSBC, Equifax, and it's if those people are not running queries at this size, then pretty much nobody needs this. And the amount of infrastructure that you have to build, the amount of difficult technology you have to build in order to sort of build these complex scale out systems is huge. I mean, just to give an example, when I was at Single Store, we one of the key features that we had a distributed database, and we wanted to do distributed two-phase commit for transactions, and that took 18 months of really ridiculously smart engineers building this thing. And in a single node database, you don't need any of that. And so a lot of what we're kind of designing MotherDuck around is hey, if you were going to design a system today, not in 2005, you probably wouldn't need to build something that is distributed. And if you don't build something distributed, if you make it scale up, you can move so much faster. And I think that was the bet that I was taking, that when we talked 2 years ago, is DuckDB is really good now, but their rate of improvement is just so high. And over 2 years, that has really played out. We've seen DuckDB, much more, kind of, it's basically feature complete now for what people need for SQL. But it's super fast. And it just keeps getting better and better, and keeps getting faster and faster. And and I think, and I think it's one of the sort of the key things when you're picking a system on top of which you want to build is like, you need to not, because in general, when you choose a database, you're not choosing, just something that is like, that you're going to use for, this next year. It's, you tend to pick things, or a data warehouse, you tend to pick things for a long, a 10-year time horizon. So what's important is not just sort of like how good something is now, but it's also the rate of change of that thing. And DuckDB, you kind of extend that out, even any reasonable amount, and like it's it's formidable.
So when you came up with this idea, with this revelation that most of the active data is under 100 gig and a lot of them under 10 gig. So you went looking so I'm curious, how did you come across DuckDB? Did you look at, let's say, Postgres, for instance, as another candidate to build a company around it?
So yeah, Postgres is, it's having its moment. It's the darling, I mean, people love Postgres, and like which, for good reason. It's an amazing database, but it's a transactional database. So it's great for, for doing, single row lookups, updates, mutations. It's not great for saying like, hey, how many orders did I do in the last quarter, broken down by region and by salesperson, and which one of my sites is doing the best. Like those kinds of questions you need an analytical database for. And so DuckDB is kind of on the analytics side. And so on the analytics side, I think there's probably some other options to choose from. But one of the really interesting things about DuckDB is just that it's an embedded database, meaning that it's just a library that you can link in. And when you link in this library, it can do some different things because it now is in your process address space, and actually has things like Python. It has access to your Python namespace, which lets you like use DuckDB in Python and query against your Python data structures and your pandas data frames. It lets you kind of have really much tighter integration with the software that you're actually writing. And kind of the other side of that is it kind of enables kind of some more interesting architectural decisions, which typically kind of the databases tend to be sort of client server, where it's like, okay, you have a client and that knows how to talk to the database, and all the work is done in the server. In DuckDB, as an embedded database, actually the work is actually done in your own process, so you don't have to marshal data nearly as much. Now, the way that interacts with a cloud service is what we did is we then have that local DuckDB talk to a cloud DuckDB, and we call them ducklings. Forgive all the duck metaphors, but so you have this local DuckDB talking to the cloud DuckDB, and you can do really interesting things about moving data to where you need it to be at the time you need it to be, and you can push workloads down to the user. So it's letting us innovate and not just kind of like what database you're using, but just sort of also how you're delivering this database as a service. And I felt like for a long time like databases had been sort of frozen in time since like Snowflake and BigQuery kind of popularized separation of storage and compute. But ever since then, everybody's sort of like kind of taking those same ideas and sort of repackaging and redoing them. And I think that there's opportunity to really innovate in like how your database, how the service is being delivered. And I hope I'm not too being sort of self-aggrandizing when I'm sort of saying that we're doing this, because I'm really excited about like how we've been able to do this. Sorry if I'm rambling a little bit, but you can.
This is great. By the way, I really like the word you use, which is, you said Snowflake popularized this separation of compute and store, because they get a lot of credit for being the first true native cloud data warehouse. But BigQuery was already doing that.
Correct? Yeah, so at one point I said to somebody, well, Snowflake, says they invented separation of storage and compute. Actually, we invented it in BigQuery, much earlier. And then somebody said, no, like, Oracle invented it even a decade, or somebody like DB2, or like somebody invented it in like the 80s. You know, I think one of the kind of key memes in databases is you know, there's sort of there's nothing new under the sun, and sort of like there's even like a popular paper that Michael Stonebreaker and Andy Pavlo and Joe Hellerstein have called like "What Goes Around Comes Around," and sort of like you see like sort of the trends in databases keep just sort of like circling around and around, and really the only constant is SQL.
SQL is a constant. I like that. So what is the growth of DuckDB today? Like how well known, how extensively is it used?
So when we started talking to the DuckDB team, they were doing 40,000 downloads a month, which is, you know, I think healthy number of downloads. 2 years later, it's 7 million downloads a month. So it's really kind of, it's shot up. It's, you know, like the you know, the DB Engines ranking, which is sort of what database nerds, you know, look at, like, you know, I think soccer fans look at the sort of the Premier League, you know, standings, and in the same way. And it started at like 250 and I think it's 64 now. And so it just, every month it goes up another couple of points. The Stack Overflow rankings, or, you know, survey just announced, results were announced yesterday, and sort of like DuckDB kind of went up considerably in terms of like just how much people are using it. But one of the really interesting things is like, it's sort of the number 3 most admired database. So like, I think they have like desires, how much people are actually using it, and then how much people actually want to use it. And so DuckDB was sort of way up there behind, you know, Postgres was number 1. You know, Postgres is super popular, but but right behind Postgres is not a bad place to be.
Yeah, absolutely. You have mentioned in the past that when you were looking for a database, you read some blog, a time zone blog of DuckDB. What is that?
Yeah, so, you know, like when we first started, it was, you know, DuckDB was pretty young or pretty early in its journey, and it was created by some academics. And one of my worries was, you know, okay, is this just the database created by academics to demonstrate, you know, that they can write papers on and demonstrate things, you know, kind of related to join algorithms, and et cetera. And but the thing that convinced me that it was for real was they read this blog post around time zones. And I remember actually in BigQuery, we resisted adding time zones for a long time. We just had actually, you know, they just said just use milliseconds, since 1970, and, you know, don't worry about time zones. Just because it's hard, it's really hard to get it absolutely right. And there's so many weird things in time zones. You know, it seems like one of those things that, it should be relatively easy, you know, like, you know, you add a day to today and it's tomorrow, and like, but, you know, there's leap seconds and smearing and times, you know, I mean, there's all kinds of just goofy things that happen. And there's actually a guy who does the time zones at DuckDB, and like he loves to just sort of talk about all the really bizarre stuff. And anyway, so he wrote a blog post about some of these things, and it's like, well, like these people, this database, you know, not only do they, you know, have they built this great academic research database, but they've also have the attention to detail that they intended to be real. They intended to be something that people can use and use in production, and that is, you know, that is really paid off. And like, there's just lots and lots of people running DuckDB in production these days.
And which academia is DuckDB developed at?
So it was created at CWI. It's a research institution in the Netherlands, in Amsterdam. It was where Python was created. So I think Guido van Rossum had been working there. They do a lot of quantum computing stuff, a lot of database stuff. Actually, the column stores were invented there. I think Peter Bonks, who's working in MotherDuck as a visiting researcher, you know, is the head of the database group there. But Marcin, I can't pronounce his last name, but he was one of the co-founders of Snowflake. Was also working there, you know, when he helped create column stores and vectorized execution. And then, Marcin went on to found Snowflake, and Peter was like, I think he wants to do something that has more impact than Snowflake. And so, I think so he's helping us, and helping the DuckDB team.
Very impressive. I had no idea. In fact, I know Snowflake founders quite well, but I didn't know there was a third person involved. But yeah, thanks for that. So since you mentioned columnar, I think let's do a deep dive on. Let's start with the architecture. So we used to have 3-tier architectures, and what trend have you seen? What is the ethos of DuckDB and hence MotherDuck?
So one of the things when we were doing BigQuery, we ran into a handful of times was, like our clients tended to be dumb. Like, so, we had a REST API and kind of, we wanted to make it simple for clients. But the problem is, like, it's really actually tricky to sort of, to get the, pull the results back as you need them. Have some caching and chunking and retries, and also there's a bunch of times where actually you may want to parse the query locally. And we said, no, we can't do that. We want to keep the clients as dumb as possible, do all the work on the server. And that limits your architecture. And so with DuckDB, we were actually able to build something interesting, which is the client is DuckDB. So DuckDB exists locally on the client as well as on the server. And this sort of opens up lots of interesting things. So we can query local data natively, super fast, sub-millisecond queries. And then we can join that with data that's in the cloud. We can move it to the cloud. We can pull data down locally. We can materialize your results locally. So if you kind of if you run the same query again, we have a result cache that's locally on your client, and you can control whether how big that is or whether we do that or not. And so we have this, we call it dual query architecture or hybrid architecture. That's kind of the basis for how how MotherDuck works. And on the server side, we have these ducklings that can scale up. They can basically scale up to the maximum size of an EC2 machine, or they can scale down to 0. And so, like, from our pricing model, you only pay for, like, essentially the CPU cycles that you're actually using.
So we used to have 3-tier architecture with a UI layer, a web application server layer, and a database. Then when you were in Google, Firebase came out with just the client and then the backend talking directly to it. So two tier. I've heard you talk about DuckDB being 1.5 tier. Is that right? Is that
so we're calling it 1.5 tier. So yeah, exactly. So like the 3-tier architecture should be client, talk to the server, which talks to the database. 2 tiers, the client can talk directly to the database, and we enable that because one of the things that we do is we'll run a separate DuckDB instance for every end user. Because we can shrink down so small, DuckDB's so lightweight, we can basically give every end user their own instance in the cloud. And so that means you can have a local machine talk directly to their own instance. And so you can do this 2-tier. But because of this hybrid architecture that I mentioned, we can actually pull data down to the client side, and we don't even have to talk to the server anymore. And, like, not everything you do that for, but like anything you can cache, anything that's available locally, can be incredibly fast. And we have some of our customers have built applications that can basically do data visualization at 60 frames per second. And that's literally impossible if you have to hit the cloud every time, just because the speed of light means you can't get to the cloud and back. You can't get to the local the data center where your analytics is running 60 times per second. But because you were able to do this stuff locally, you can basically sort of build the type of interactivity that is it's impossible to do in a more traditional way.
So this makes me realize or think of microservices architecture, because in microservices, you got, let's say it's a financial services, you got microservices for different functions. Would DuckDB be a good choice in that case to have it be a part of each microservice?
Yeah, so I mean, DuckDB is great. You can run it in like, in serverless, mechanisms. You can run it in Lambda. Yeah, and it's just super low, it's, super lightweight. It runs in the web browser. So if you go to like shell.duckdb.org, like that's a full-blown DuckDB that, runs in your web browser and can query data that lives on S3. And so MotherDuck also we run in the web browser, and so we have our web UI, for example, runs in your web browser. So and I think because of this, people are using DuckDB in all sorts of interesting ways, like in sort of the nooks and crannies between systems. You need to translate some data somewhere, and like it's super versatile.
Got it. So is that using WASM when it runs in UI in a web browser?
Yeah, exactly. It runs in WASM WebAssembly.
Can you just, for the viewers, tell us what is WASM and what does it do?
Sure, yeah, it's a technology that lets you sort of run arbitrary code in a web browser. I think it started as like asm.js, as a sort of being able to run x86 assembly kind of is interpreted in JavaScript, which sounded sort of insane. And then, you're able to sort of compile it down to something that actually, runs pretty fast. And there's been a bunch of additions that are built on top of it, or ways that you can interact with the network. And so, DuckDB being a very small, C++ binary, can essentially run in this WebAssembly environment. So you get a full-blown database running in your browser.
So WebAssembly, I think that's what WASM is. So the advantage of WASM is that you can then write your code in any language of your choice. It could be Rust, it could be Java. So WASM will compile it, and since DuckDB is running in WASM, so I can write my front end in Rust and still be able to use DuckDB. Is that correct?
Yeah, exactly. And I think in general, the closer it is to machine code, the better WebAssembly works, or the better WASM works, just because it it interprets machine code. But you can write you can build sort of really robust applications using and reasonably lightweight applications using this, and then inside WASM you can run any language you want.
And you had mentioned earlier that you can write your code in run it in the browser, and it talks to files on S3. So let's talk about storage. What are the storage file formats you store, and how is that connection made?
So by default, we use, we store data stored in DuckDB's native file format. We store that in the cloud. And there's a lot of advantages to that. Like there's a lot of research that's gone into, really kind of state-of-the-art, compression algorithms
it's column.
It's a columnar storage format, but there's all sorts of interesting things you can do once you start doing column-based storage of your data, from like, how do you store the strings? Do you store the strings like in dictionaries and then indexes into those dictionaries, or compressing floating point numbers, like, which in general usually are considered uncompressible, but like there's techniques that you can do to sort of if there's a bunch of numbers that are actually reasonably similar, to be able to sort of compress those reasonably. There's a lot of it's sort of an active research problem. But anyway, a lot of that stuff has gone into DuckDB. So there's the DuckDB format that we actually store. So DuckDB, as like most databases, it assumes that it can read and write kind of arbitrarily from files. Now, if you want to store something in the cloud, that becomes tricky, because cloud object stores tend to be append only. And so you can't go back and you can't go back and like change one row or one thing without rewriting the whole thing. And so what we built is we've sort of built this differential storage system that we can it ends up being appends, but then we layer that over to be able, the existing one to be able to do, to be able to do updates. So, we've sort of built this, way to be able to do read write to DuckDB and separate storage and compute in the cloud. So that's sort of the standard MotherDuck storage mechanism. But then also, data lakes, lake houses are, quite popular these days. Lots of data is stored in Parquet files or CSV files in, on S3, on GCS, etc. And we make it, which are very easy to just query those. And so, DuckDB, you can just do select star from S3 : object name dot Parquet, and it'll run that query. So it's makes it, they really have nailed the developer experience, just to make it really simple to do things that seem like they should be simple. And you can do the same thing with Iceberg files or Parquet data, or Delta data. Some of those things are, Iceberg and Delta are a little bit kind of early days, but those extensions are getting better and better for DuckDB, and because we do see more and more people using those formats or wanting to use those formats. And it's also, I guess it's also a good thing for us, because if you're using Redshift and storing data in Redshift, then we can't access that data, and so we have to convince a customer to export the data somewhere. If you're using Snowflake, we have to convince the customer to export the data from Snowflake. But if somebody's storing their data in Iceberg and they're using Snowflake, then we have the same ability to access that data as Snowflake does. So it's a lot easier for us to sort of, try things out and kind of convince customers that, hey, check out this workload. We think we can do it, an order of magnitude less expensively and a lot faster. And when it's a lighter lift, it's just querying the data in Iceberg. It makes it a lot easier.
This is such a hot topic these days. Lake houses with table formats, Iceberg, Delta, Hoodie. So I don't have to move my data into Snowflake proprietary format. I can leave it on S3 Parquet with Iceberg, and then you're saying we can use DuckDB to query it much faster.
Yes, I mean the one the one downside to these formats, and I think is sort of underappreciated, is you lose probably an order of magnitude of performance. Like, it doesn't matter what query engine you're using, but if you don't have a query engine that's essentially tightly coupled to the storage, then you're just not going to be able to do things as fast. Like, some things are not going to work as well. Updates are going to be harder. Like, fresh, being able to sort of do rapid updates is going to be hard. Like, there's a bunch of things that that get uglier and less pleasant. But I think often, performance is good enough that people don't care, and the benefits you get of kind of being able to sort of access from multiple different engines is outweighs the problems. And I think it's also why things like Snowflake does a lot of stuff under the covers to sort of do a lot of caching, and so it looks like it's all in kind of just on S3, but they also cache the metadata.
Correct. Yes. So let's talk about the query engine in DuckDB. What kind of query engine? By the way, this is a confusion I sometimes have with DuckDB. Should I think of DuckDB as a database, or sometimes just as a query engine, or what is the story around DuckDB as a query engine?
So I mean, DuckDB is an analytical database. So I mean, similar to and it's sort of, I would say, it's sort of the analytics equivalent of SQLite. And SQLite I think is the most commonly used database in the world. Like, there's probably in my phone, there's 100 different apps that use SQLite in some form or another. And so I would say DuckDB is similar to that, only it enables you to answer different kinds of questions. It is a vectorized query engine, optimized for use in column stores. It's it was created by folks in research, and so a lot of the really kind of most recent academic ideas and research ideas are incorporated, and it's quite fast and well designed. I think a lot of research these days is sort of being done, and since it's open source, people are like, hey, in order to get my master's or my PhD, I'm going to implement this thing on top of DuckDB. And some of those things work out, and some of those things don't work out. It's like, yeah, well, it turns out to be not a big deal or not really productionizable, but sometimes they're productionizable, and the best ones, they go back into, they get merged back into DuckDB. So like there's been a lot of really cool stuff that's been able to go into DuckDB. I was actually just in Amsterdam the week before last, and like attended a master's thesis like of somebody who was like adding like kind of an optimization for a certain type of join, and he's like, yeah, and then at the end we were able to commit that back to DuckDB, and so now a subset of queries are going to get faster, but it's also nice when just sort of the community is the one that's sort of making it better, rather than having to rely on sort of a small set of of people who are kind of.
So I remember from my Oracle days, there was a lot of work we had to do with locks, latches, and then when Hadoop came, there's a lot of like overhead with shuffle. All that goes away if it's a single node, or it gets minimized quite a bit, I'm guessing.
Things are dramatically simpler. Shuffle, like, yeah, in BigQuery, shuffle was a big deal. Like, we had several engineers working on like how to optimally move data from one machine to the other. And if you have a join, like, because one key might be over in one table is going to be on one machine, and another table the matching key is on another machine. So you have to be able to co-locate those things. And that's a hard problem. And in a single node system, it's just, you just build a hash table and share the pointer to the hash table. And it ends up being a little bit more complicated than that. Like, you share multiple, you create a hash table per thread, or you need multiple, like, but at the end of the day, it's just like, it's so much easier. Locking is still hard, but also like two-phase commit is so much easier. And you don't have to worry about kind of things arbitrarily failing. You do have to worry about sometimes, things aren't necessarily like, even though in a single machine, if they're in different like NUMA zones, they may end up like you may not want to have too much. It may be almost like it's on a network, but again, these are much simpler problems than sort of dealing with distributed systems.
Talking about query engine, going back to that, do you support like full ANSI level SQL?
Yeah, so it's a SQL. ANSI SQL is based on Postgres. So they basically, when they started DuckDB, they kind of forked the Postgres parser, and it's still Postgres compatible. And in terms of semantics, I tend to take their cues from like, okay, what are the Postgres semantics? But then there's a bunch of stuff in Postgres that is just sort of not very conducive to analytics, or like there's ways that are just easier SQL to write. And I think that's one of the cool things that DuckDB has started to add is like, hey, like we keep having to sort of, you have to repeat the columns in the select projection list with the, the group by the aggregation list. Like that seems goofy. Like, why not just to do it in one place and then use group by all? And so they added that syntax, and now like, BigQuery, Snowflake, a lot of other query engines have implemented group by all, and they have a number of these sort of innovations that you don't have to use. You can write just pure ANSI standard SQL, but if you want to write something that's a little bit simpler, this function chaining, and they have some really cool stuff in DuckDB.
I see. And you had mentioned earlier on when you were talking about you have your own proprietary columnar storage, but then you can go off Parquet files, and you've also mentioned CSV in the past. How you have a CSV parser. You mentioned it's the world's best CSV parser. What do you mean by that?
So I think this is one of those interesting things that as a database person, you really tend to focus on like, you know, for performance purposes, like how do I, when someone gives me a query, how do I make sure that I can return the results as fast as possible? But for a user, that's actually not what performance means. For a user is, I have a problem to solve. How do I solve that as fast as possible? And very often, somebody's got like a nasty, hairy CSV file that was exported from some, weird tool. And you try to query over that. And, first of all, how do I match up the schema, and how do I figure out what's in it, and then how do I query it, and then, oh, there was a problem in it. There's a story, actually, I did a site visit when I was in BigQuery, and actually a very large company, potential customer, the CTO was like evaluating BigQuery, and he was like trying to like see how it works, and he was like, he wasn't able to make heads or tails, but wasn't able to get it to work. So I go in and I sit down with this like very high-powered CTO, and he's like, BigQuery just doesn't work. And he was showing me what he was trying to do, and he was like, he was trying to import a CSV file, and he was missing a comma somewhere, because he had to define the schema, and like you had to list all the fields, and like it's like you squint, this really, really long line, like, oh, you're missing a comma here. And then he added that, no, that works. Well, that's all he needed from me. And so like just all this extra work, time, energy, frustration, getting the CSV file in. And so, I think one of the things that the DuckDB team has done is they've said like, hey, CSV is really important to get right, and it's hard. And so they basically wrote multiple research papers on how to do this well, and how to parallelize it, how to infer what the data types are without and what the values are without having to scan it multiple times, and as a result they have just this great CSV parser, so you can just like select star from this CSV, and it's just going to work, and it's going to figure out what it needs to do, and it's going to figure out what the columns are, and it's going to figure out whether there's a header row or not, and they can figure out what the delimiter is, and you can specify those things if you want. It's got to like, it'll write out if there's errors, like it'll write just the rows that have errors to like another table. Like there's all sorts of like just great things in the CSV parser. And it's just a different approach than most database companies take, because most database companies, including when I was at BigQuery, treat CSV as like, hey, this is like not that important, and like, just have some CSV parser, and like the important stuff happens once that gets in. And just from a user perspective, that's like, it turns out to just, if that's where you spend your time, then that's where the database team should spend their time. And I think DuckDB is one of the few companies that actually, takes that seriously.
How do you handle unstructured data, or semi-structured and unstructured? Like, Snowflake and now Databricks introduced in June of this year also a variant data type. So how do you handle JSON kind of semi-structured and unstructured?
So, I mean, DuckDB has really great support for semi-structured data, which kind of can include like nested arrays and objects. A lot of that work was actually done at the behest of Lloyd Tabb, who was the Looker founder, and now is working on Malloy at Meta. And one of the things actually, so it's really cool about BigQuery is BigQuery kind of, because it originally started as being able to query over protocol buffers at Google. It's very good at dealing with sort of nested and kind of repeated fields, like nested structures. And Lloyd realized that this is actually really, really useful for a certain type of BI to be able to run one query, so a single pass query that can kind of fold and unfold into these nested structures. He was one of the only people that who could actually understand this, but he did amazing things with it. But anyway, so he has been working with the DuckDB team to get them to add this support so that he can do the same kinds of things in DuckDB as are in BigQuery. so it's got really good nested, repeated, structured support, semi-structured support. There's in terms of like completely unstructured data, there is a blob type and vector types, but kind of not really what you probably would want to use to store like your kind of image files in blobs. But I think that one of the other nice things about DuckDB is it has a really, really rich extension mechanism, and now a new community extension mechanism. So basically, kind of you can add community extensions, and then anybody can just load those by as long as they know the name of the extension. But you can do kind of unstructured stuff in some of these extensions, and there's also vector support and AI.
Do you have a native vector data type? And what I mean by that is, can I use DuckDB, point to a PDF, and then say, read this PDF, call OpenAI's embedding model, generate embeddings, and store it natively in DuckDB?
So you can't necessarily do that. You could do that in an extension. Like, so DuckDB doesn't know how to read a PDF, and so would have to be able to figure out how to parse the PDF. But there is, so in MotherDuck, we're actually next week, we're releasing an embeddings API. So you'll be able to sort of turn a string field into a varchar field into kind of into an embedding vector. And then, and their DuckDB has sort of native cosine similarity functions that you would want to do for vector similarity. They also have a vector, extension that can do fast vector search. But I think the part about sort of parsing it from the PDF file is, to my knowledge, doesn't exist, but somebody might have written that extension. Somebody wrote an extension that can read from like Excel files, which comes in handy.
So talking about queries, I have seen there's been an explosion of different type of query engines. Facebook created Presto, then Starburst Trino, we have Dremio, we've got something called Velox now with Gluten. How are these compute engines competing with DuckDB's compute, and what trends do you see in this space?
There is a trend towards sort of a decoupling of systems. I think Velox is the sort of the most interesting one of it. They kind of said, hey, you can sort of plug in different storage, different optimizers, different parsers, and sort of it's kind of it's a nice idea, and they've got it working for a couple things. I think sort of the jury's out whether that's actually going to be the way systems get built in the future, just because there is such a benefit to tight coupling. I guess I'm sort of a loose coupling skeptic, that I may turn out to be spectacularly wrong in the future, but that's just sort of how I see things. I see there is like sort of a trend towards towards native code, and either kind of something that's written in C++ or Rust, over like these sort of Java-based systems. I think Presto, Trino were originally in Java, Dremio is Java, and I think just from a performance perspective, I don't want to start language wars here, but like performance perspective, is really hard to sort of get the same level of kind of native performance. And if you're dealing with like giant MapReduce things, giant Spark jobs or whatever, kind of the language doesn't necessarily matter. But I think when you want to do with sort of like kind of improve latency, it's really got to be in something native code like C++ or Rust. And I think that's why like Spark, which is also Java, was has the Presto kind of C++, sorry, what was it called, Photon, C++ execution engine underneath. but it's sort of still kind of within this Java framework, which I think slows it down.
Yeah, which is interesting because Databricks SQL, it's all of Databricks is about Spark, but when they wrote Photon, they use C++. So I think that goes to prove your point. So Jordan, there's so many more questions I have. We're coming toward the end of our time, but I just want to ask you, I see Snowflake and Databricks, all the hyperscalers, they're producing these very vertically integrated stacks. And it's got data catalog, data quality, observability, data ops built in. How do you compete with these vertically integrated stacks? And how do you monetize?
So it's a good question. But I think one question to ask is like, are they building these vertically integrated stacks because customers are asking for that, or are they building them because they kind of are like, well, we need to sort of push into the what are the next adjacent things that we can do? I suspect it's a little bit of the latter, that it's sort of like, hey, well, we did the data warehousing, or we did the data science, and then the kind of like this thing is the next thing, and this thing is the next thing, or so I don't know that it's sort of necessary to build all those other things and to have a vertically integrated stack. I do think that, you know, a lot of those, you know, the pieces that you mentioned have, you know, open source or third-party analogs. And I think as long as, especially if data is being stored in kind of open formats and open locations, then it becomes, you know, you basically have the same access to those locations, open catalogs. You know, and also, how do we monetize? You know, is basically we're a SaaS service. You know, I worked at, you know, a company that was trying to sell shrink wrap software and move that into the cloud, and like it's just so much easier to justify these days, like charging somebody for running a service versus charging them for like a software license. You know, I feel like it's a more scalable and, you know, better way to build a business. You know, we'll see how it works.
So I've one last question, and it's got nothing to do with technology, but it has to do with the name of the company, MotherDuck. How did you come up with this name? Because it's very funny and actually amusing to see how you use a lot of innuendos, and I won't go there right now. But do you see a problem with some of the traditional conservative enterprises with the name of the company?
I don't know what kind of innuendo you're talking about. Like it's a mother duck. You must have a dirty mind or something.
Of course. Yeah, obviously.
No, so it was the name was created by Lloyd Tabb, the Looker founder. You know, he was the one that kind of convinced me to start a company in the first place, and he was brainstorming with me on some names. I wanted to call it subquery because I was thinking like, you know, smaller queries, and he kind of sent me a text and said, you know, MotherDuck, and he said, plus the domain name is available. And I thought like, haha, you know, you can't name a company MotherDuck. That would just be, you know, wrong. And then I clicked on the link that he sent, and where the name was available, domain name was available, and like it's like $65,000. And like, haha, you know, that would be, you know, double. That's how I knew he was joking. And then I think I said haha, and he said, no, I'm serious. I'm good at naming things. Trust me, this is a good name. So I'm like, but you can't really name a company that. And like in all my initial things, I had said MotherDuck, and in parentheses I said working name. And then it turned out it sort of sticks. It's, you know, it's memorable. You know, people don't forget it. It's actually descriptive. You know, because we're kind of taking these, you know, DuckDB little ducklings, and we're kind of, you know, marshaling them and kind of keeping track of them in the cloud. And I think, you know, in terms of whether enterprises will balk at using it, like, I think that if it, you know, like if CockroachDB can be successful, Splunk can be successful. Like, I think, you know, people will use it if it's useful and if it solves their problems.
And Sanchmo.
Sanchmo, yes.
This has been amazing. Thank you so much. I love your sense of humor and your depth of knowledge in this space. Really liked having you discuss this. So many more topics. I think we should do more of these.
Yeah, well, thanks so much for having me on. Looking forward to our next conversation.
Thank you. Great. Have a great day, everyone. Thanks for joining.